So welcome back to the second part of the lesson. So I'm going on with number 2. When we do this, the limit notation, we're always finding delta x. Delta x equals 9 minus 1 over n. That's 8 over n. We are then going to look for a plus delta x. And when we do that, since we're going from 1 to 9, we can talk about this is 1 plus, or 1 comma, 1 plus 8 over n. And so we now know that's the a plus delta x. It's a plus delta x. And so when we go to finish this, we're now doing the limit as n approaches infinity of delta x, 8 over n, multiplied by f of, which we know is 3 square roots, of a is the 1, plus delta x, 8 over n, multiplied by k. And again, I'm just going right from here. Delta x, we found 8 over n. We found the a plus delta x right here. So f of, that's the function, 3 square roots of a, 1, plus 8 over n times k. Okay. So I'm going to do number 3. You're going to pause it and finish number 4. So delta x equals 7 minus 2 over n, so that equals 5 over n. We have 2 to 7, 2 to 7, so we're going to get here 2 plus 5 over n to be our a plus delta x. So we're going to get the limit as n approaches infinity of 5 over n multiplied by ln of 2 plus 5 over nk. So you're going to pause it and you're going to try number 4. And hopefully that is what you got for number 4. So now we're going to kind of switch gears and we're going to go backwards here. Let n be a positive integer and write each one as an integral. So now we want to figure out what the bounds are, what the function is, and then how to finish it off. So if we look here, the bounds, this is going to give us our a value. So I know that we're going to start at 1. That's what this is going to give us. Then I know that the change, delta x, was 2. So I know that 1 plus 2 equals 3. So I know we're going to go from 1 to 3. And then I got to figure out what my function is, the f of x is. So I know we have a 1. So it's going to be 1 over. And what is it? Well, it's 1 over 1 plus something. This is a delta x. Well, this entire thing right here is what we're kind of dividing by. So 1 over x dx. So if we can do number 6. There is no addition here. So we know that our starting value must be a, or a equals 0, because there's nothing being added there. And we know that we know that the change delta x is pi, so we know we must be going from 0 to pi. It's a sine function, sine of x dx. So in this case, we're looking at what our a is. In this one, there is nothing. What our delta x was. The change in x, we're going to do a plus the delta x to give us our top limit, and then our top bound, and then we're going to figure out what the actual function is. That's what we did there for 5 and 6. For this one, we're going to write each area. We got to write it again as a definite integral, and then it asks us to evaluate it. Right now, we'll just write it as the definite integral. We don't have to evaluate it. So when we look at this, this is our delta x, that pi. And again, there's nothing being added, so we know our a equals 0. So we're going to go from 0 to pi, and clearly this is our function right there. So cosine of x dx. The one other thing that I just forgot here is that there's a k, so we know that it's x cosine x dx. Let me rewrite that for you. Got a little ahead of myself there. So we go 0 to pi. This is another variable. We have a k there, which shows us it's a variable. So we're going to go x cosine x dx. That was my fault. In the last part here, we know that we're getting something squared. And this 2, we know that's what we're adding, so that's our a value. This is our delta x, so we know we're going to go from 2 to 5, since the change in x was 3, so 2 plus 3 is 5. We got of x squared dx. And to finish off with the joke, which I know I've been lacking in some of these videos, why did the scarecrow win an award? So why did the scarecrow win an award? Because he was outstanding in his field. Get it? Outstanding. So the scarecrow was outstanding in his field. Have a good day, and I'll see you in class.